Hi, I'm Jim Lewis from Model Train Technology. In this video, we're going to discuss the setup and configuration of the Precision Detectors. They're fairly straightforward. The manual is very specific about how to use it, but occasionally folks get stuck, and so we're going to go through it. I have both the N scale and the HO versions. They're identical in function and electronics. They're just on a different form factor, and so we're going to go through that right now. Now I'm going to zoom up so you can see what we're doing, and we're going to go through all of the steps. Okay, for this demonstration I'm going to use one of our power modules. I've already connected up the electrical wire. For each sensor there are 3 wires. Oops, got this wrapped around my microphone. There we go. There are 3 wires, 2 red and a yellow. Okay, and in the case of the power module, it doesn't matter which terminals you use as long as you use 2 adjacent terminals. You don't have to figure out positive and negative. So for testing out and starting up, we recommend that you simply connect up the 2 red wires only and leave the yellow wire, signal wire, free. Okay, so we'll start with the HO detector right here. I'm going to turn the power off. Okay, the sensor is up here. There is a push button, what we call the select button, and 2 trim potentiometers, so we call them trim pots for short. Okay, and the way in both cases, they're different, which one is which. So there are 2 functions. There's one that adjusts the timeout, so that is that once the sensor is tripped and then released, it will hold the trip state for as long as you have the trip sensor. So the train goes by, but it'll wait a little bit of time before it releases the sensor. And the way to remember for me is we want to set it to the right time. So in the case of the HO, it's R for right time, it's the right side. And for the N scale, it's RT, or right time T, for the top one. So it's the right side on the HO and the top one on the N scale for the time adjustment. So to test this and make sure everything is working, we want to make this as simple as possible. So in each case, we want to set the time to the shortest time possible. Okay, so we're going to set this right hand trim pot to all the way to the counterclockwise left position. All right, and on the case of the N scale, it's the top one. We provide you the screwdriver, you know that already, and the top one is all the way to the counter to the right. Okay, so I'm going to plug this in without the power on. I'm going to show you the back, and when I turn the power on, the first thing that should happen always on all precision sensors, it should flash 4 times. And then, since my hand is blocking the sensor, it went on. If I take my hand away, it's off. So if it doesn't blink 4 times, or it's a pulsing LED, so about 1 a second, that means there's something wrong with the sensor. So right away, don't try to futz with all of the mechanicals and the other things, the settings. If it doesn't flash 4 times right after you turn the power off, so it's about a 1 to 2 delay, there it goes. All right, take my hand away and the sensor's off. So that tells you that it's working. All right, the second thing that I recommend is, all right, so we got the right time to immediate. We're going to set the left time. I'm going to turn it all the way counterclockwise to 0. We'll talk about that in a minute. And then I'm going to turn it back to about halfway, which is the vertical position. That'll give it about 3 or 4 inches of detect zone. And I'm going to turn the power on. You'll see the light blink, okay? And now, when I put my hand in about 4 inches, it's about 3 inches, you can see the light going on. So I have it in immediate mode. So what can happen? All right, so the detector has a mode called inverse. So you could actually, you might have actually pushed the button, and this would be 5 times. So I'm going to set it to inverse mode. 1, 2, 3, 4, 5. And it's going to repeat back to me those 5 blinks. And now it's on, or the inverse of detect, it's on all the time until I put my hand in front of it. So if you get this behavior where the light won't go off and there's nothing in front of it, the most likely cause it's in inverse mode. Okay, and to test that, just put your hand in front, it goes off, turns back on. The way to fix that, again, it's a toggle, 1, 2, 3, 4, 5. And now it'll go on when my hand is there and go off when it's not, all right? Those are the first two things that you can do to test the operation of the sensor. If those two things are working, then probably everything else on the sensor is working, okay? So now let's configure this for a slower time. So I'm going to go to the right side and I'm going to turn it to the right-hand side. You can do this while the power's on. And I'm going to turn it to about the 11 o'clock position. Now before, when I put my hand in front of it and took it away, the light stayed on. Now it will stay on for about 15 seconds. And you can make it go all the way up for the first setting. So let's do it one more time. So that's simulating a train going by and the sensor staying live for about 10 to 15 seconds. Now in standard mode, out of the box, the first range is from 0 to 30. But sometimes you might observe the effect where it's staying on at a minimum of 30 and it goes all the way up to a minute. And the reason is we wanted to keep the precision of this dial to 30 seconds. So to add, if you wanted to have a 45-second timeout, you push the button 4 times. 1, 2, 3, 4. And now the minimum time that it will stay on will be 30 seconds, and you can adjust that from 30 to 60 seconds. Okay, so we're not going to sit here and watch this. But if the sensor comes on and you say, it's not going off, well, if you wait long enough and the sensor is working, in fact, it will go off. All right, well, let's just wait. Okay, we've got a few minutes here. In train time, 30 seconds is forever. And there it goes. All right, let's get it out of that mode. 1, 2, 3, 4. And now, whoop, I have to adjust this back down again. Let's do it again. It's going to time out. So I set the timer back to 0. I set it to get out of the added time mode. In fact, what we can do if we want to skip that step is we can just restart it, turn the power on and off. And now, what did I do? Maybe I didn't press it the right number of times. 1, 2, 3, 4. Yeah, that's it. Okay. So I probably hit it not enough times, all right? So now let's talk about the range mode, all right? One of the things about all the sensors is in the range mode to 0 will be auto-calibrate. So if you turn this all the way down, back down, and the auto-calibration hasn't been set, you might get a little crazy because nothing's happening. So what I recommend, as I said before, is adjust the distance to about the 11 o'clock position and then test the sensor, okay? So that's a really good way. You can go all the way up, turn it all the way up so that you've got the full range, which is about 5 inches. You can see how precise that is. Okay? All right, so make sure that you don't have it set to 0. Anytime it's set to 0, it's in auto-calibrate mode, but I haven't set this sensor, so nothing's happening. So I'm going to use this sanding block here to auto-calibrate, all right? And so the way to auto-calibrate is just to push and hold the select button. The light will go on and off, and then it will come back on. That's when you release the button. And if you can see, the LED is blinking. It's going to give you a few seconds to get your train car into position, and just hold it there. And when it blinks rapidly, it's now set the auto-calibrate, and since that's where I want it to be, it's on. If I move this away, it'll go off, okay? All right? So you have to be in the 0 position for the distance, and you have to set auto-calibrate, all right? So there it is. Now, if I wanted to adjust this, let's say I wanted to make it closer than this, or maybe farther away, all right? Now I take it out of auto-calibrate mode, all right? So take it away from 0 and keep dialing it up until the sensor light goes on, and now that's the distance between the sensor and the block, and it's not using auto-calibrate. Now if I want to use auto-calibrate that was preset, that I just did a minute ago, I take this and I dial it back all the way to 0. All right, you saw the sensor go off, and now my calibrate distance from before is active. All right, so that's how auto-calibrate works. All right, so let's just do that really quickly with the N scale. It's the same thing. The top is the time. Okay, the light works. Great. All right, the bottom is the range. I'm going to take it all the way to 0. Nothing's happening because I don't have auto-calibrate set. I'm going to push and hold the button. The light goes off. And when it comes back on, it's ready to do its auto-calibrate. It's going to blink slowly about every 2 seconds to tell you get ready, put your train car where you want it. All right, those rapid blinking means it's set. And now the auto-calibrate range has been set, okay? And let's say I want to take it out of auto-calibrate and have it even be shorter than the auto-calibrate. I just turned it a little bit, moving closer, 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 closer. So it's really close now, okay? Now the other thing is that there's a range. So if we push this button once, the range is from the sensor all the way to whatever you set it at. Now you can also set it for a narrow range where it won't detect before that and won't detect after that. For N scale, which is a 9 millimeter, the range of the rail, you push it twice. Okay, so now watch what happens. All right, so I'm going to come in. It's going to detect and not. Okay, so let's put it into HO range. You can still use these N scale for HO cars. There we go. 1, 2. Oh, let's just make sure. 1, 2, 3. 1, 2, 3. Okay. So here we go. Let's make the range a little bit further out so you can tell what's going on there. Okay, so now the range adjustment just moves that narrow band, which in the case of HO is a 15 millimeter band. So you see that that would be the beginning of the rail, that would be the second rail, and it's off, okay? So it's only going to detect the range in the rail. So for starters and for setting it up and debugging, just push it once, and that gives you the whole range that you have set, okay? So it doesn't go off. All right, so the last thing I want to show you is, and something could have gone wrong with the signal wire. I have the signal wire attached here. I'm going to place this over here. I have a fiber optic signal controller, and I'm going to turn the power off, and I'm going to connect the signal wire from this detector to the detect side of the signal controller. There we go. Okay, so there's the signal controller. As it faces you, the detect is the bottom. All right, so we have a separate video on debugging and configuring the signal controller. That's later. All right, so we're just going to turn this on. And what you're going to see is that's the green output. Okay? Let me get this. Let's do this one over here. Whoops, do I have the right wire? Yeah, okay, let's go back to the HO. Get it to boot up. And now we know that the signal works for HO. I have this on very rapid. So now I know that the signal's working because it's changing the signal controller. So that's a quick video on how to set up and configure and troubleshoot the precision detectors. First thing to do, disconnect any signal wire that you have. All right, so just keep it simple. Turn the power on and make sure that the light blinks 4 times. After that, test it for range as we talked about, and then you can connect it to your signal controller and go from there.